Okay. Yeah. Okay, I'm back with a bit of a modified circuit here. Now the IR LED, the indicator LED right here, only turns on when it's receiving a signal. So, like, say I take a handy dandy remote here and point it, you'll see it that the LED. Turn off the light. LED blinks in response to signals from the IR. And that's being also pumped into the Arduino over here with that white cable, and getting data here on my board. And this is telling me, I've written this little program to tell me how long the on bursts are. So, like, if you imagine you've got your 38 kilohertz carrier signal, and then on top of that you've got on, off, on, off, on, off. So this is telling you how long all the ons are. So you can see a certain button on this remote will generate kind of a stream of numbers here, and those are kind of averages. You'd figure out what code was coming off the remote by the pulse length and direction. Well, what I've done is hooked up this infrared emitting LED to a transistor, and this little wire here will turn on and off the transistor. So you see when I connect this, the IR goes across to the detector and the little LED lights up in response. I've tuned it exactly using this pot and the little fine tuner pot to the right carrier frequency, and if you look over here, we've got data coming in. And a short pulse, this is in microseconds, so it's really fine control. Short pulse gives me about, a certain amount of time. If I hold it in for a while, let go, it gives me a much larger number, so it's accurately measuring the time. And I suppose I can hold it back here. If you see 1 Mississippi, 2 Mississippi, 3 Mississippi, and take off. The last number on there is just about, well, I guess that's about 3 seconds. I'm not sure how many microseconds are actually in a second, but 1 Mississippi, 2 Mississippi, 3 Mississippi, 4 Mississippi. Yeah, I guess it is. That's about 4 seconds right there. So it's timing accurately. Of course, I'm not. But what I'm going to try to do next is that little timer circuit down there. It's a 556 timer, and what that means is, like I said earlier, it's got 2 timers on it. I'm going to try and do one side doing the carrier frequency, 38 kilohertz, and then the other side doing a set number of pulses on, off at a much slower frequency. And by using both sides of the timer, I should be able to make a signal that's identifiable and pick something I can pick up on the Arduino. Unfortunately, I can't time pulses and generate pulses at the same time on the Arduino and use the same unit to pick it up. So what I'm going to try and do is do it all on this one little circuit, one little self-contained unit, and eventually maybe I'll etch a board that will do this in a much smaller kind of form factor. Alright, I'm back like 2 weeks later. You might notice my beard's a little longer. That's how you can tell. Actually, it's October 21st, 2008, and I finally got this thing working. As you can see down here, I've got, maybe you can't see, this is my circuit design here. It's a 556 timer. That's handling, this side here is handling the carrier frequency, this side is handling the pulse. I went through a couple designs actually on this board, and this board kind of sucks. It's been resoldered 10 billion times. I decided just to start fresh. And luckily the first try I managed to get everything right here. I got all the resistance values and capacitance values right. What's especially different about this one is the IC circuit isn't driving the LED over here. This is my IR LED. It isn't driving it directly. There's 2 transistors here, and each one is being switched by the IC chip. So that way, I'm not relying on the IC chip to handle voltage for the IR. It's just switching these transistors on and off, allowing current to flow directly from the power source to the IR LED through a small resistor, so I can get the best brightness out of it, basically. And this little pot handles the carrier frequency, but luckily I've got it tuned to where I can pretty much turn this pot anywhere and it stays in tune. It's a very narrow tuning. This one right here handles the pulse width, and that's when I build more of these boards, it's going to let me distinguish between boards by handling how often that deal pulses. Now the actual circuit design, let's see if I can get a good shot of this so I can save it, is right here. And I just wrote this up real quick based on some stuff I found on the internet. If you actually want to see it, it's right here. This is my original one-side circuit design for a 555 timer, and by extrapolating it out to the 556, I did the math. You can see all the capacitance or the resistance values and whatnot over there. Well, they've got some sun on them, but they work. Anyway, I've got that running. I've also built a little detector here. It consists of an IR detector. This particular detector demodulates the signal itself, so it takes the 38 kilohertz carrier frequency, demodulates it, and it just gives me the pulses, so that saves me a lot of circuitry. We've got a little capacitor here running from the ground to the power source for it. That just helps eliminate any false positives. If you take this off, this little indicator LED would be going kind of crazy right now. As you can see, I got a remote here. It gives me a nice clean signal. And I've also got a wire running into this. Is not an Arduino, this is a Freeduino. It's an open source copy. It was like 11 bucks. I highly recommend it. You have to build it yourself, but I mean, you have to get one of these special USB kind of cables. Hooks up to my computer right here. But once you have that, I mean, you can program like I don't know how many different Arduinos with that. It was like a $20 cable, but I highly recommend getting these if you don't mind soldering them up yourself. Now, if I go ahead and plug this in to my power here. There we go, and I'll line it up. You can see, and once I've got this puppy lined up right in the line of sight, I'm getting a nice pulse here. And if I take this screwdriver here and adjust this pot, let me see if I can do it without. I gotta put the camera down. I'm sorry. Maybe I can get them both in frame. Yeah, I can. Take this screwdriver right here, adjust the pot. You'll notice that it slows down to only a few times per second, and then faster, and it speeds up. So that's really nice. That's exactly what I wanted. And if we actually look at the data coming out of here, I'm getting somewhere in the range of what would that be? I'm really not sure. That's in. I'd have to do the math, but I know that's microseconds right there between pulses. And I'm gonna go ahead and put this down. See if you can keep an eye on it right here. If I change the if I change the pot and I turn it down up, you'll notice that the time in between each interval increases. That's even slower. So that's a pulse every probably 1/7 of a second, and that's probably every 1/4 of a second, or 4/10 of a second, sorry, and that's 7/10 of a second. So I've got a pretty wide range here. I could almost divide by 10,000 to figure out which one I'm pointing at. Now, unfortunately, I'm not going to be able to test this with two of them until I go buy some more stuff. But now that I know how to build this, I've got a prototype. It shouldn't be that hard. And there you go. That is an IR circuit. It's hard to do this when you're not looking at it. That's a nice little circuit for driving infrared communication.